Hi, welcome to another Algebra 1 video. Today we're going to learn about section 2.1, which is solving inequalities using addition and subtraction. In this video we will learn about solving simple linear inequalities involving addition and subtraction. We will also graph the solutions to inequalities on a number line so we can understand the answers visually. So let's begin solving some inequalities using addition. Solving inequalities is just like solving equations. You use the properties of equalities to solve simple inequalities as well. So I'm about to teach you how to solve some examples of inequalities, and we're just going to treat the inequality signs like an equal sign. So here is my first inequality that we have to solve. We're given that b minus 2 is greater than 9. And we know that we have to treat the inequality sign just like an equal sign when we solve equations. So here I can see that we have to apply the inverse operation of addition so that I can get rid of that negative 2 from this side. So I can add 2 on each side of the inequality, just like an equation. And then I've successfully isolated my variable b. And then b equals to 9 plus 2, which is 11. So this answer tells us that all the values of b that satisfy this equation are greater than 11. So let's graph this inequality on a number line. We can see that all the values that satisfy the inequality start from 11. Except 11 is not included because it's greater than 11. So from the last video we know that if something is not included, then we mark it with an open circle. And since 11 is not included in this inequality solutions, we mark it as an open circle. We also know that the solutions are greater than 11, so we can extend a line from the circle to the right side of the number line. So this ray that I've drawn here shows us the solutions that satisfy this inequality. So say pick a number 12. If we plug in 12 is greater than 11, which is true. So 12 is in this area of the number line. Here I have another question which says that 3 over 4 is greater than y minus 1 over 4. So again we can apply the inverse operation of addition, and we can treat this inequality sign like an equal sign, just like when we solve equations. So I can see that on this inequality I can add on each side 1 over 4. And if I do that, I get rid of that negative 1 over 4 and the plus 1 over 4 as they cancel out to 0. And then we're simply left with y on the right side of the equation. And we put the inequality sign, and then we simplify this side of the equation. 3 over 4 plus 1 over 4 is simply 4 over 4, which simplifies to 1. But I can see that on this inequality, 1 is on the left side of the equation, and our variable y is on the right side of the equation. Normally we like to have the variable on the left side of the inequality. So to do this I can swap the inequality sign, giving us y is less than 1, which is equivalent to 1 is greater than y. Now let's graph this inequality on a number line. We know that the solutions to this inequality are y is less than 1. So all the values of y that are less than 1 can satisfy this inequality. And our inequality sign is less than, meaning that it does not include the 1 as a solution. So all our values have to be less than 1. So on this number line I can place an open circle on 1 because 1 is not included in the solution. And the inequality sign is less than, so we can take the number line from the circle to the left side of the number line. And to verify, if we plug in negative 1 into this inequality, then indeed negative 1 is less than 1. Now let's solve some simple inequalities using subtraction. Solving inequalities using subtraction is the same as solving inequalities using addition. So here I have number 1, which says that p plus 0.7 is greater than negative 2.3. So just like solving equations, we can pretend that this greater sign is an equal sign. So here I can see that I can use the subtraction property of equality. So I can subtract 0.7 from each side of the inequality. And by doing this, I get rid of that 0.7 and the negative 0.7, which cancel out to 0, giving us only p on the left side of the equation. And then on the right side of the inequality, we have negative 2.3 minus 0.7. And this simplifies to negative 3. So p is greater than negative 3 is our solution to the inequality. So what does this solution tell us about the answer? Well, it tells us that p can only be a solution such that the values are greater than negative 3, where negative 3 is not included in the solution. So p consists of answers that are greater than negative 3. So we know that p is greater than negative 3, and we know that the starting point of the graph is going to be at negative 3. So we can mark a point here. But we don't know if it's going to have to be filled or it's going to be an empty circle. Well, if we look at the inequality sign, it says that p is greater than negative 3. And this means that the circle should not be filled because negative 3 is not part of the solution, as negative 3 is not greater than negative 3. And then we have to determine if the ray is going to be in this direction or in this direction. Well, it says that p is greater than negative 3, So it should be in this direction, as all these numbers on this side of the inequality are greater than -3. So this way graphically shows our solutions to this inequality. Here on number 2 I have another inequality which says that z plus 1/6 is greater than or equal to 5/6. So again, just like solving simple linear equations, we just pretend that this inequality sign is an equal sign, and we don't have to worry about anything else. In this inequality, I can see that 1/6 is being added to z, and so I can isolate the variable z by subtracting 1/6 on each side of the inequality. So by doing that, I get plus 1/6 minus 1/6, and then I do minus 1/6 on this side as well. And then I can cancel out the plus 1/6 and the negative 1/6, giving us a 0 over here, plus a z, which is the remainder, greater than or equal to 5/6 minus 1/6, which is 4/6. And then I see that I can simplify this inequality, as 4/6 can be simplified to 2/3. So our solutions for z in this inequality are such that z is greater than or equal to 2/3. So this means that only values that are equal to 2/3 and greater than 2/3 satisfy this inequality. Now let's graph this inequality on a number line. So I know that the starting point of this inequality on the graph is going to be at 2/3 because the answer is z is greater than or equal to 2/3. So we can mark a circle here. Now we have to determine if it's going to be a filled circle or an open circle. Well, we can see that by the inequality sign, which says that it's greater than or equal to 2/3. Since we have that equal on that inequality sign, it has to include 2/3 as part of the solution. And then on the other hand, we see that it's also greater than. So we have to include all numbers that are greater than 2/3. So all the numbers that include 2/3 and those that are greater than 2/3 are part of this inequality solution. So we can check that by plugging in 10 into this inequality, and 10 plus 1/6 is indeed greater than 5/6. And this is it for section 2.2. I hope you liked this video and you found the concepts of solving inequalities using addition and subtraction helpful. In the next video, we're going to learn about the same thing, except we're going to use the inverse operations of multiplication and division. Also leave a comment in the comment section and provide feedback so I can improve my videos in the future. And I'll see you in the next video. Thanks for watching.